Alright, hey guys, welcome to a video today. We're going to talk about finding slope. We're going to look at finding slope through a graph. We're going to look at finding ordered pairs from a table, and we'll even try a couple of equations. Alright, before we get started, let's kind of go back and remember, and let's remind everyone about Slope Dude's journey. Remember, Slope Dude will help you out a little bit as you go through these, trying to find these problems and trying to determine if it's a positive slope or whatever slope we're looking for. Okay, if you remember, as Slope Dude is coming through his journey, well, his first step is going up the hill. Remember, he said this is hard work. This is positive. Puff, puff, positive. So we're going uphill is positive. When he got to the top, he started skiing downhill. He said, hey, this is nice. I can go pretty easy. This is nice. So nice, negative. And when he got to the flat part, remember we talked about him being the hard part. This is the hard part of his journey. And he said this is zero fun. Well, if you'll notice, zero here has a line that is flat, zero fun, and it's a horizontal line. So sometimes you can kind of put together the z's in zero and horizontal to kind of help you out. Well, when he got to the end, remember, he said, oh, he didn't see that cliff, and he fell off the cliff, and he said the bad word. He said, oh, this is undefined. So the four types of slopes are positive, negative, zero, and undefined. Okay, so let's look at how we figure out some slopes. Remember, our definition of slope, as we talk about this, we're talking about the rise over the run. In other words, we're looking at the change in the y values over the change in the x values. And remember, we always talk about we want to start, it doesn't really matter, but we want to start at the lowest point, and we read graph. Remember, we read a graph from left to right, just as we're reading. So this graph, we're going to determine which direction it's going. Well, before I get started, if I was to draw Slope Dude here, and I use him to determine his journey, well, if I go back over here and look, he's kind of going uphill, so it's a positive slope. So we know my answer should be something positive. It's just we have to determine what the slope's going to be, the rise and the run. Well, if I start at this lowest point and I count up and I count over, well, if I count up, it's 1, 2, 3. So my rise is 3 and my run is 1. So rise is 3, run is 1. So if I reduce that and simplify it all the way down, my slope, remember they used a lowercase m, is 3. And we can check that by saying, oh, let's try it one more time. Well, if I go from this point to this point, what's my rise? What's my run? Well, that's 3, and that's 1 again. So I have 3 and 1. Okay. What if I wanted to use, say, this point and this point, or maybe even this point? Well, if I want to rise up here, okay, you don't have to use those points. Remember, we try to use the lowest point. So if I use this one, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rise is 9. The run is 1, 2, 3. So I have a rise of 9 and a run of 3. Well, if I want to reduce that, the greatest common factor is 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. So again, 3 over 1 gives me 3. So the slope of this line is 3. All right, let's check this one. Okay, well, if I look here, remember we read a graph from left to right. So I would draw Slope Dude on this side, and I would look over here, and he's going downhill left to right. So this one will be a negative slope. We just need to figure out what the actual number is from the slope. Well, still remember, doesn't really matter, but I always use the low point to the high point. Okay, so let's use this dot. Let's draw our slope. We're going to do our rise and our run. Well, if I rise, 1, 2, and I run, 1, 2, 3. Okay, so my rise over my run, or the change in y over the change in x. Rise was 2. Run was 3, so up 2 over 3. And since I went left, or since Slope Dude is going downhill, the slope of this one is m equals negative 2/3. So the slope of this line is negative 2 over 3. Let me redraw that just a little bit. Slope of the line is negative 2 over 3. I still need to draw a little bit better. Sorry. Okay, so negative 2 over 3. All right, so if you look up again, if we go up 2 over 3, up 2 over 3, rise is 2, run is 3, rise is 2, run is 3. So it's a constant slope, constant rate of change, okay? All right, Let's look at this one. Now this one's a little different. It doesn't have any points on it, so we've got to figure out where to put a point. So remember what we're looking first. We're going to draw a slope dude. Let's talk about him first. Which way is he going? Well, he's going uphill. So this one is going to be a positive slope. We just need to figure out what are the rise, what is the run of this line. Well, if I don't have any dots, I need to find a place to put some dots. So I need a minimum of at least 2 dots. So if I look, what I want to do is I want to find a place where I can put a dot to where it would meet a vertical line and a horizontal line and my blue line all meet at the same intersection or the same corner. Well, if I start looking very low, if I look right here, if I see right here, I can put a dot right there because it meets this vertical line, it meets this horizontal line, and it meets this diagonal line. And as I keep going, I'm looking for another one that meets right in a corner. Well, there's one. And we can keep going all the way up through here. There's another one. Okay, we can keep going and keep going. There's another one. Well, I only need 2 lines to find my slope. So let's go ahead and do what we got here. So we have our rise and we have our run. Let's see what they're going to be for this one. Well, for slope dude to rise up and over, he rose up 1, 2, 3, and he ran over 1, 2. So my rise was 3 and my run was 2. And since he's going uphill, it's a positive slope, 3 over 2. Okay, so this is the slope of this line, and all I'm doing is counting rise to run, 3 and 2, 3 and 2. I can use that point. I can use this rise and this run to do another point. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I could keep going on and on and on if this line kept going, if my grid was big enough. But you kind of get the point. It's just rise over run. All right. Next one, let's see what we got. All right, now we got one that's going this direction. Remember, we draw slope dude on the left side, and we check which way is he going. Well, here he seems to be going downhill, so he's doing the nice negative slope. So then let's figure out what we have here. Rise over run. Now here again, we don't have any points, so let's find out some points. Well, if I start looking, I start going down. I know definitely I can put one here because it touches the y-axis and this x and this blue line. Well, let's keep going. I can't put one here. I can't put one here. Not here. No, I can put one here. All right. So let's find our rise and our run. All right. So if I count rise and I count run, 1, 2 is my rise. And then from this point, 1, 2, 3, 4, 5. So my rise is 2 and my run is 5. Well, when I check with slope dude, he's coming downhill. So that means my slope is going to be a negative 2/5. 2 over 5. Okay. And I can use that rise and that run to put some more dots if I needed to. 1, 2, 1, 2, 3, 4, 5. All right, so we're going to talk about more about adding dots later, but right now all I want you to do is be able to find that slope. All right, well, let's look at this one. Well, if this is another part of slope dude's journey, if I draw slope dude here, he's not going up or down. This is the part where he's on that flat part. So this one should be a 0 slope. Okay, well, let's kind of show what we did before. So let's do the same thing. We have our rise, and we're looking for the run. Well, if I'm looking, I can put a dot anywhere on here because it's touching a vertical line, a horizontal, and it's actually touching the horizontal line anyway. Okay, so if I'm looking, if I was to go from this dot to this dot, I didn't go up and I didn't go down, so my rise is 0. Well, my run is 1. And anytime we look at this, if I have 0 divided by 1, then my rise over my run gives me a slope of 0. So this is the 0 fun part of slope dude's journey. All right, let's see what the next one says. Okay, are you following along? All right, here we go. Let's try this one. All right, now we have a vertical line. All right, so again, this is the part where he comes to his journey where he falls. So this one should be a little bit different as far as the way it's set up. So let's see. I can put a dot here. I can put a dot here. I can put a dot way down here. All right, so let's look at our rise. Let's look at the run. Well, if I start at this point, If I was to rise up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can do a rise of 12. But did I go left or right at all to go from this point to this point? No, I just went straight up. So my run is 0. Well, if you remember, when I put this in my calculator, it's going to tell me this is an error. I can't do this. So this is a undefined slope. Okay, because this is a calculator error. It's going to say cannot divide by 0 error on our calculator. So this is the undefined slope. It's the vertical line. It's up and down. Okay, plus remember the little rhyme we talked about. If the zero is beneath the line, the slope is undefined. Okay, all right. Let's see what we got here. Okay, now we have some pairs, and I don't have a graph. All I have is the ordered pairs. Well, remember, the actual way we do this is y2 minus y1 over x2 minus x1. Remember, this is x1. This is this is y1, excuse me. This is x2. This is y2. There's nothing wrong with that. You can do it that way, and that's the way you're going to learn it a lot. But remember, we just did it the simplified way. We just created a t-chart, and we created our t-chart, and we placed our numbers in the t-chart. And please make sure you remember you write these as they're written. So when x is 5, y was negative 5, y was 10. When x is negative 3, y is 14. Okay? So all we're going to do now is we're going to figure out the change in x and the change in y. So we're going to look at, again, our rise and our run. So we're looking at the change in y, which is my rise, okay, over the change in x, which is my run. So all we're going to do is do the change in the values, okay, and then we got to simplify. So here we go. So if I do change in y over change in x. Well, if I start at 10 and I go to 14, well, 14 minus 10 is 4. Okay, so it's still y2 minus y1. All right. If I started at negative 5 and I went to negative 3, I actually went up and I added 2. Okay, so I have a plus 4 for a rise and a plus 2 for a run. So plus 4 over plus 2. 4 divided by 2 gives me 2. And then a positive divided by a positive is a positive. So my slope of the line that passes through these 2 points is 2. So remember, it's the same concept. It's just set up, it's just a visual difference, okay? All right, let's try this one. 12, 4, and 7, 2. Well, this time we're just going to go ahead and write our ordered pairs. Remember, this is the run, and your y is your rise. So we're going to set it up as 12, 4, 7, 2. Well, I started at 4 and I ended at 2, so on my number line I would have went down 2. Started at 12, ended at 7, which means I would have went down 5. So the change in y over the change in x, or your rise over your run, is negative 2 over negative 5. Well, the slope is going to be, I can't reduce 2 over 5, so we're going to leave it as 2 over 5. And if I check my signs, remember, a negative divided by negative is a positive. So even though we went down on both of these, it actually works out to be a positive slope line. So always just check with your signs the last thing. Okay? All right, let's see what we got here. All right, let's look at this pair. So we have x, we have our y, let's make our t-charts. We have 2 and 18 and 7 and 18. Okay, remember again, this is the run, this is the rise. All right, so the change from here to here, I started at 18, I ended at 18, is 0, or 18 minus 18 is 0 if you wanted to do the y2 minus y1. Okay, all right, so from here to here, 2 and 7, I went up 5, or 7 minus 2 is 5. So either way you wanted to do it. So my rise over my run gives me 0 over 5. And if I put that in my calculator, I should get 0 over 5. Remember, 0 divided by anything is 0. So my slope of this line that passes through these 2 points is 0. Now another giveaway, if you look right here, if you'll notice, both of your y values are the same number. Okay, so that tells you if you were to just kind of freehand graph this, 218 would be here, 718 would be here. It would be a flat line, which would give you that zero slope. So you can kind of sometimes look at the order pairs, and sometimes it will help you out. It will actually give it away to you. Okay, all right. Let's look at the next one. All right, then we're going to take those same order pairs and we're going to reverse it. So we're going to actually swap them up and change it. So what do you think is going to happen here? Think about it a minute. What do you think is going to happen to this line? What should it be? What should the slope be? Okay. All right. Well, let's see what it's going to be. Well, if I put in my x and I put in my y, I have 18 and 2 and 18 and 7. Remember, this pair is here and this pair is here, right? Well, if I started at 2 and I went up, I added 5, or 7 minus 2 gives me 5. And same thing here, 18 to 18 is 0, or 18 minus 18 is 0. Well, this time I have my rise over my run gives me 5 over 0. Well, remember, if I put in 5 over 0 in my calculator, it's going to tell me that's an error, which means I cannot do that. So this answer would be undefined. And again, if you could graph this, it would be something like 18's way over here and 2, and then 18's way over here and 7. It would actually be a vertical line, which with vertical lines are undefined. Okay, plus here's the 0. All right, let's see what else we got. All right, now we have a table. Well, remember, what you have on this table is the same concept that we just did. This is going to be your run. This is your rise. We're going to just find the difference. Let's just find the difference. Negative 10 to negative 4. All I did was I added 6. Okay, negative 4 to 2, I added 6. 2 to 8, I added 6. And 8 to 14, I added 6. All right, let's check the y side. The x side. So negative 1 to 2, I added 3. 2 to 5, I added 3. 5 to 8, I added 3, and 8 to 11, I added 3. So it's the same thing we did before with y2 minus 1. If I take this number, negative 4 minus a negative 10, would give me that same positive 6. So it's the same concept of y2 minus y1. It's just you have a bunch more of them to do. Okay, so my rise over my run, or my change in y values over my change in x values, is plus 6 over plus 3. Well, if I need to reduce this, 6 over 3 is 2, and then positive divided by positive is a positive. So the slope of this line that passes through all 5 of those points is positive 2. All right, let's see what we got. All right, let's go one couple more. So we have 8 to 6. Remember, this is my run. This is the rise. X is run, Y is rise. Change in Y over change in X. Up and down divided by left and right. So if I started at 8 and went to 6, I went down 2. 6 to 4, I went down 2. 4 to 2, down 2. And 2 to 0, I went down 2. So you see I have a constant change over here of down 2. Let's see what happens on the X side. Well, I went plus 4. 7 to 11, I added 4. 11 to 15, I added 4. And 15 to 19, I added 4. All right, so I have a rise. And we have the run. The rise was minus 2. The run was plus 4. All right, so now we got to do a little reduction here because this fraction is not in lowest terms, so we need to reduce this fraction. So again, the greatest common factor of 2 and 4 is 2. So I'm going to divide both of these by 2. Negative 2 divided by 2 gives me negative 1. And then 4 divided by 2 gives me 2. Alright, so now if I look, negative divided by positive is a negative, so I can't reduce it anymore. So my answer is negative 1/2. That looks like 1/4, sorry. So my answer should be negative, that looks like 1/4 again, sorry. Negative 1/2. So the slope of the line that passes through this table is negative 1/2. I think we're getting almost to the end of this. Let's just go a couple more. All right. Again, run, rise. Well, if I look, all of these numbers are the same. So that means I didn't do anything. I didn't go up or down, left or right into. So that should give you an idea now. If we didn't do any change on the y side, Now you can go up or down. That should give you a little hint of what kind of the slope's going to be. But let's see. If I started at -7 and I went to -12, that's subtracting 5. I subtracted 5 here. I subtracted 5 here. And I subtracted 5 here. Well, if I look again, rise over run, or again, the change in the y values divided by the change in the x values. 0 over -5. Well, anything 0 divided by anything is 0. So the slope of this line that passes through these 5 points is 0. All right, let's try a couple more. All right, this next one, if I'm going from 12.5 to 15, oh my goodness, we got some decimals. So we got to do a little regrouping here, because I know we don't like decimals, right? But remember, guys, decimals are not scary. Just use them as like anything else, okay? So if I started at 12.5 and I went to 15, that means I added 2.5. If I started at 15 and went to 17.5, I added 2.5. So the common change here, the common rate of change, or the constant rate of change, excuse me, is adding 2.5 on the y side. Well, on the x side, if you'll look, we didn't change anything. All these are the same numbers. So we have run and we have rise. All right. So rise over run, in this case, is 2.5 over 0. Well, if you put that in your calculator, it's going to tell you that's an error. So that's the one we're looking for right here. So the slope of this one is undefined. Remember, he fell off the cliff. He fell off the mountain. This is a vertical line straight up and down at 21.5 on the x-axis. Okay? 0's beneath the line. The slope is undefined. So all you do, remember, is just looking at the x values, looking at the y values, and setting up that ratio of rise to run, and then simplifying if it can be simplified. All right? Okay, let's see what we got here. What we want to do now, we want to do a little proving about some slopes of triangles. Well, if I look right here, we can draw. Let's find the slope of a couple of these. Let's draw this triangle right here. If I want to find out, I want to prove similarity between two different triangles. I want to prove the similarity. I want to see if they're similar. Remember, we talked about similarity and congruent. Congruent means exact same size, exact same shape, exact same angle measurements. Well, similar means same shape, same angle measurements, but just a little bit different size. Okay, so we talked about this today in class. We talk about looking at these ratios of the slope. Well, if I check this slope and if I check this slope, if I can simplify them and they are the same, then that means they have the same shape but different size, but the ratios of their slopes going to be the same. We'll make them similar. All right, so let's check the red one right quick. Let's check A to B. So my rise is 1, 2, 3, 4, 5, and my run is 1, 2, 3, 4, 5. So I have a 5 to 5 rise to run, which gives me a slope of +1, since slope dude is going uphill. All right, let's check the purple. Let's check the ratio of the purple. 1, 2, 3, 4 over 1, 2, 3, 4. Okay, so I have a ratio of 4 to 4. Rise to run. Rise to run gives me the same ratio. If I reduce that, gives me 1. So what this tells me is triangle A and B, the slope between A and B is the same between B and C, which means these two triangles are similar. They are similar triangles because the simplified ratio of both of these triangles is the same, 1 and 1. All right, let's try another one. All right, here's another one. Now look at these dots. They're a little bit farther apart. So let's do a couple. Let's try this from B to C. So if I want to go from B to C, well, my rise is 1 and my run is 1, 2, 3, 4. So from B to C, I have a ratio of 1 to 4. That can't be reduced, but what I need to look at is where his slope dude at. Well, he's going downhill, so his slope is -1/4. Okay, so slope dude's going downhill on B to C. Well, let's check A. Let's just check A to B. So I want to go up and I want to go over. All right, well, if they're similar, I should reduce this to -1/4. So let's see. Went up 1, 2, and I went over what? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, the ratio of rise to run is 2 over 8. Well, 2 over 8 and 1 over 4 are different numbers, but what I can see I can do a little reducing. Well, both of these are divisible by 2, which gives me 2 divided by 2 is 1, and 8 divided by 2 is 4. And then when I look over here again, I use slope. Do it again. He's going downhill from here to here, from B to A is downhill. So if I look, the slope here is negative 1/4. The slope here is negative 1/4. So these two triangles are similar. Okay? So that's all we're doing with these is we're checking the ratio. We're checking the ratio from these ratios of the slope. Really, if you remember, we call that the hypotenuse of the right triangle. So really, I'm checking the slope of the hypotenuse to prove the similarity between those two triangles. All right? Well, I think that's a lot of work to look at today, and I hope you enjoyed the video. If you need to go back and look at it again, please do. And let me know what you think about these tomorrow in class if you are watching them, and maybe a way we can make them a little bit better. Okay? Thank you, everybody. Talk to you tomorrow.